For this morning, before we start our class, we are going to see where we are now. Let me share my screen. Okay, so based on our scheme of work, now we are at week 6. So we have already discussed on the principle of stability. Okay, ni principle of stability, equilibrium, and today we are going to continue another part of equilibrium, and we are going to talk about torque, T-O-R-Q-U-E, and also how we want to determine center of gravity based on equation. Kita akan kira macam mana. Okay, macam mana kita nak provekan the possibilities of center of gravity and how we are going to find equilibrium inside center of gravity. This is what we are going to do today lah. Okay, so let's get back to our notes. Alright, so these are the notes that we are going to use today. Yes, stability in motion. The topic is still stability in motions. Mean we try to have a fluent execution of motion, and in order to get a fluent execution we need to have stability in the motion itself. So nanti kita tengok apa maksud stability ni, okay? So these are the definition we have learned beforehand. What is stability, what is balance? Let's recap it a bit. Okay, so stability is a resistance to disruption of equilibrium. So the term that play a lot here is actually equilibrium. Okay, ini adalah apa yang kita dah belajar sebelum ini, dan ini juga apa yang kita perlu faham. Okay, so the first thing, again I recap it a bit, is about equilibrium. So what does it mean by equilibrium? There are always two states. Okay, where one of the state is known as static equilibrium and another one is known as dynamic equilibrium. Okay, so static equilibrium and dynamic equilibrium share one thing, and the thing that they are sharing is actually the absence of acceleration. Okay, benda ni tak ada. And when you have an absence of acceleration, what you are going to get is actually two things. Okay, bila absence of acceleration terjadi, you are going to get two things. One, we known as static condition, where an unmovable object will remain unmovable, or you are going to get the second form of it, which is movable object will remain movable at constant velocity. Okay, either of this is the state of equilibrium. Okay, why? Ini tidak bergerak, ini bergerak, yet it bergerak at a constant velocity. And this only occurs because of one thing, because of there are no force. Force of what? Okay, first, force horizontal, this kind of force. Second thing, force vertical, this kind of force. And the third thing is any, okay, or this kind of force, which cause object to have rotational effect. Okay, and this one is known as torque. This is what we are going to learn today. Okay, the continuation of equilibrium itself. Okay, so if you take a look at the notes, alright, so the first one is stability, means a resistance to disruption of equilibrium. Okay, it can be further explained by this concept. Okay, by this concept. Okay, I'm going to show you an example. Let's say we have a box. This box is 100 kg. Okay, means it has a force of 1000 Newton. Okay, 100 times 10. Alright, if we apply a force of, let's say, 200 Newton. Box ni 1000 Newton. You apply force of 200. Bergerak tak? Can this box move? Can this box move? Boleh tak? Oh, dah masuk lah. Boleh tak kotak ni bergerak? If we apply 200
Boleh.
Newton. Boleh tak boleh? Kotak 1000 kilo. 1000 Newton. Application of force 200. Can this box move?
Cannot move.
Tak boleh.
Cannot move lah.
Tak boleh.
Because force applied is lesser than resistance. Terbalik lah. Force applied is lesser than the resistance. Okay, means it does not move. When we apply something to the box, to the item, and the item does not move, this item is known as a stable item because it resists disruption of equilibrium. Tapi kalau kotak ni, we apply force and it move, meaning it has velocity. When it has velocity, it caused by acceleration. This is the main cause of disruption. Benda paling mudah. So when there are no acceleration, there won't be any velocity, there won't be any movement. Bila tidak ada movement at all, this is known as stable. Stable condition. Okay, we have two phallus. Si kecil and another phallus. Si bulat. Which one is much easier for you to push? A?
Kecil.
Yes, A. Much easier. So, when you push this person and it move, he is not stable. Okay, dia pun bergerak setapak, dua tapak, and now he stop. When he stop, he is now stable because velocity 0, acceleration 0. This is stable. Okay, second one is balance. We have people, and these people wobbling left and right when you push, yet he does not move forward. This is the act of try to maintain stable. The action of trying to maintaining stable. This is known as balance. So differentiate those two. Stability is when you don't have any acceleration. Means you are not moving. If you are moving, okay, this is point 1. At point 2, it is the same velocity. This is stable because there are no acceleration. If there are acceleration at the first point, you are going to be 2. At second point, you are going to be something else. Maybe 5, maybe 6, maybe 1. Change of velocity caused by acceleration. Have acceleration, not stable. Okay, that is stability. Balance, in other hand, is when you try to maintain stable. Naik basikal, okay, you ride a bike. Katalah kita tengok daripada depan ni orang bawa basikal, this is the handlebar. Okay, and he start to wobble left and right because he don't want to fall down. This wobbling, when this fella feel like want to fall on the right hand side, he shift his weight to left hand side. When he feel he want to fall down on left hand side, he shift his weight on right hand side. That action is balance. Okay. Oh, jangan lepas jumpa, kau tak balance lah. No. Balance is an action of maintaining equilibrium. Kau tak stable, yes. Kenapa dia tak stable? Dia bergerak nak jatuh kat kiri dengan dekat kanan. So, when we are going to see he is stable, when the action is no acceleration. Means the action is constant. So, that will be the concept that we are going to discuss today. Stability and balance. Okay. Right, let's proceed. So, those two have a lot in common, and that is actually equilibrium, like the first slide. Okay, where equilibrium can be divided into two, which is static equilibrium and dynamic equilibrium. Okay, although there are two types of equilibrium, those equilibrium share a major properties, which is they don't have any magnitude. Magnitude vertical, upwards, no. Magnitude horizontal, in a straight line, no. And magnitude in terms of torque, which is cause of rotational. Jadi hari ni kita akan bincang torque, since we have discussed the first part regarding stability and equilibrium. Alright. To understand torque, we need to know two type of force. Okay. Kita ada banyak type of force, but as for today, we are going to discuss only two type of force. First one, torque. Okay. It caused by force. Okay. And this force need to have a distance between point of application and the axis of rotation. Okay, so these are the formula or mathematical model representing torque. Okay, you have force, you have distance. Sometime you're going to see torque as this one. It will be weight and again radius or distance. These two things is equal. Sama je sebenarnya. Force is a force, push or pull action, and being defined in terms of Newton. Weight is mass time gravity, which resulting a unit of Newton. So it is the same thing. Jadi jangan terperanjat. If you open up book McGuinness, book, it will write torque as this one, T equals to WR. But if you open Susan J. Hall book, it will write torque as the left hand side. Torque equals to FD. So these two things is equal. Now, let's talk about the first part. Ni, apa benda sebenarnya force ni? Okay, so in torque, in order to get torque, we need a force known as eccentric force. So, the partner for eccentric force is known as centric force. Okay, centric force, eccentric force. So what are these two things? I'll explain that with an example. Let's say we have a book. Okay, in your opinion, where is the center of this book mass? Kat mana center gravity dia? Kat sini ke? Kat sini ke? Dekat sini ke? A, B, C. Which one do you think the center of the gravity is located? A, B or C?
B.
Why?
B. B.
Why?
Because it is at the center.
Because it is at the center. Quite good one. Okay, kalau kamu tengok dekat sini, saya rasa saya dah bagi penerangan ni. Sekejap We go center of gravity. Look, center of gravity is the point in the body or system around which its mass or weight is evenly distributed. Betul lah jawapan kamu tadi. That is center of gravity. The second term is center of mass. It's the point in a body or system at which for certain purposes the entire mass may be assumed to be concentrated. These two things is different, but since it serves the same purpose, we can determine, we can predict, we can put both are equivalent terms. So that is the reason why most of the time center of gravity is actually in the middle. Okay. Lagi-lagi benda solid macam ni, the thing that does not change in terms of shape. Like manusia, okay, we can actually say our center of gravity being located in the middle of us, which is dekat kita punya belly button. However, if we change position, let's say this is standing upright, we change to kedudukan membongkok macam ni. Where do you think our center of gravity will be located? Is it still in the middle of us, or is it going to be out of our body? Ni tak perlu jawab. Okay, this is, you don't need to answer this one. This is the difference between solid and things that change. So center of gravity do change places. Okay, from here it become there according to situation. But in a solid state, it does not change. The weight will be evenly distributed. Okay, now to understand centric and eccentric, okay, we have two terms here, centric and eccentric force. Okay, centric force is force that being delivered directly to the center of gravity. Okay, that kind of force. Okay, kita namakan dia sebagai force A. What do you think going to happen to this book if we apply that kind of force? Dia jadi apa? Apa jadi dengan buku ni? Kita bagi force macam ni. It will cause the book to move. Pergerakan dia macam mana? Can somebody predict? You just put a book on the table beside you and push the book through the spine. Straight dia tolak dia pergi depan. It cause the book to move. Macam ni kan?
Straight.
Ataupun it cause a linear motion, or to be exact, it cause a translation. So centric force will always cause translation. In other words, centric force is comprising of only horizontal force or vertical force. Contoh kita bagi kat sini. It cause the book to move forward. To move upward. This is centric force. So lawan dia, supposedly kamu dah boleh tangkap lah. Eccentric force is when the force being delivered to the object, not towards the COG. Okay, we name it as force centric, force eccentric. Okay, now, based on the second one, what do you think is going to happen to the book? Apa jadi bila kita bagi FE instead of FC? Okay, letak buku dekat depan masing-masing and try to push dekat dia punya at the top. Okay, at the edge of the top ataupun at the edge of the bottom. If let's say this is the amount of force being delivered to this area, impulse at here, it cause the book to move like this. Dapat tak?
Dapat, sir.
Okay, ini apa dia? Curvilinear. Is curvilinear some sort of rotation? Dia rotate tak?
Rotate, sir.
Rotate kan? Okay, now we have rotation. Means eccentric force is the force that cause torque. Okay, now when we do eccentric force, this kind of force give you all V, H, and T. Now we have torque. We have rotation. The more force you give, the more or the faster the rotation is going to be. Cuma you still going to have pergerakan ke depan. Okay, kita tetap ada pergerakan ke depan. The book is not going to rotate at one place. But the thing that I want you to have it is that eccentric force is actually force that being given not straight to the center of gravity, and it will cause rotation. Okay, so under eccentric force, we have another one known as couple force. Okay, nampak couple force? Nampak couple force apa yang first thing kamu bayangkan? Dia akan ada berapa banyak force?
Dua.
Dua lah. Alright, so now, this couple force, when we talk about couple force, this force need to be given in the same magnitude, but different direction. So if you give one couple force, we name it as FE1 here. So another FE need to be in vice versa condition, in contrast to the first one. The same amount. Okay, now what do you think is going to happen when we have these two couple force? Kita dah tak ada ni. What do you think is going to happen? We give one force, Fe1, at the top edge of the book, and we give Fe2 at the bottom contrast edge of the book. What is going to happen to the book itself? Now you are going to see
Rotation.
Rotation, sir.
ataupun nama kampung dia Tokui. Torque. Okay, inilah torque. Okay, it is torque. So torque is actually rotation caused by eccentric force. Okay, ni bukan concentric eccentric tau, bukan contraction extension. Eccentric force, force that been given not towards the center of gravity. It will cause rotation. Bagilah dekat mana pun, it will cause rotation. Okay, so now we have the F part. Okay, we have the F part. The D part, distance. Okay. When we have something like this, first, we need to determine which direction the force move. Okay, I'm going to the next page. Okay, we are going to, we need to know which direction the force move. Okay, and from that which direction, you need to have a clear line. Imaginary line. This is the line of force. Okay, and then you need to determine the axis of rotation. Okay, now you need to draw a line intersect with the axis of rotation parallel, okay, with the line of force. This is known as line of rotation. Okay, in between these two, these are the line that connecting these two, and this line serve as R ataupun D. Ni dia ada contoh T terbalik kat belakang ni to show it is actually distance. Okay, these are the distance. Okay, apa nama distance ni? Some books call it as R, radius. Some book call it as D. But the name here is actually force arm. Ini nama dia, force arm. So katalah tadi kita ada Fe2 kat sini kan. So this will be the line of force. In between line of force and line of rotation, these are dia punya radius or force arm yang kedua. Yang ni ialah force arm yang pertama. Okay, sampai sini dulu. Can you understand it? Basic of torque.
Yes, sir.
Alright. Now, let's take this particular system into human. Okay, into human motion. We take the simple one. We take our arm. Okay, this will serve as the elbow. Okay, and here you have your palm, you have your weight. Okay, weight bergerak ke mana? Atas ke bawah? Normal. Kita bukan buat concentric action, just a normal. It will move
Bawah.
right? Okay, so at the same time, you're going to have your muscles here. This one is going to be your bicep, and we have attachment of the biceps towards your forearm. Bicep contract menyebabkan pergerakan tangan ke mana? It will cause the hand to move
Upward.
forward. Macam ni. Can you see the torque here? We have elbow. Saya padam elbow ni. Elbow ni menyusahkan hidup kita kan. Okay. Yeah. Is anybody? Okay. Alright, Dr. Nadia, thank you. Okay. This elbow, ni kan? This is actually the axis of rotation. Now can you see torque? 1F. Resistance is always weight. 2F. 2F works in different condition. Can you see this one? Masuk. Nampak tak? Can you see the torque? Now, Hello. Aduh. Bukan. Terputus. Dah. Sorry, putus. Dengar tak?
Dengar, sir.
Siapa yang memutuskan perjalanan kita? Sekejap Aku cakap sorang-sorang rupanya tadi. Alright. Sambung Sekejap. Cakap tengah sonok ni. Okay. Can you see this one?
Sir.
Yes, sir.
Okay. Now I have deleted the elbow. I changed that to axis of rotation. That is your axis of rotation. Your force of bicep is moving upward and the weight itself moving downward. Can you see? Can you see the torque there? Nampak tak torque ni? Nampak tak pergerakan yang menghasilkan torque? Can you see that? Nampak tak?
Sebab ada couple
Yes.
movement ke?
Sebab ada couple of force working from different side. Tengok buku tu balik. 1 and 2. Axis of rotation. This cause rotational action. Same goes as your bicep. The force at the bicep cause contraction upwards. The force of the weight cause extension downwards. That is torque in human. Dapat? Dapat tangkap?
Macam kurang, sir.
Oh, macam kurang. Can you understand this diagram yang bawah ni, buku ni? Satu force here, satu force there. Dapat kan? Okay. So concept of torque, first you need to have axis. 2, you need to have couple force. 3, different direction of application. 3 benda ni je. Now, do you have all of these 3 in this human body part?
Yes, sir.
Couple action, couple force, different direction application, axis of rotation, torque. And that is the reason why most of human movement is actually torque. Dekat lutut ada torque, we have torque dekat ankle, we have torque dekat leher, all those things that known as joint causing torque.
Kalau dekat wrist pun ada torque juga ke?
Sama. All joint causing torque because when we move, we are implied to gravity. At the same time, we have muscle force acting in different direction. So it cause torque, it cause rotation. Kan kita punya human movement, everything is angular motion. Do you still remember that? So angular motion is caused by the presence of torque. To torque. Okay. Sekarang saya nak masukkan konsep torque ni, this one to the what we call it, to the equilibrium. Macam mana kita panggil torque kat tangan ni equilibrium. Okay. Ingat konsep yang tadi when we have torque, we need to find out F and distance. Okay. So in this case, there are 2 complex of torque. The first complex is the contraction complex. So dekat mana F dia? Force being applied or force being produced by muscles. Dekat mana dia punya D? Distance, this one. Distance between attachment of bicep towards the axis. Ni dia punya D. Ataupun ini yang kita panggil sebagai force arm. And the second complex is the complex of resistance. This one. Where the resistance will give the force and the distance is between the middle of the resistance to the axis. Distance always towards the axis. Okay, distance always towards the axis. So we name it as resistance arm. So to make this complex equilibrium, we know that in equilibrium, torque equals to 0. Okay, this one is equilibrium state. So, if we have two components, meaning that torque force need to be equal with torque resistance. Kalau torque force dia 100, torque resistance dia 100. So, resulting, no difference. Means, you are going to have an equilibrium state, no movement at all. So now let's see. Let's try. Okay, let's say this resistance is 20 Newton. Okay, 20 Newton. And the distance between the resistance and the axis of rotation is 38 cm. Kita assume lah panjang tangan kita ni 38. Okay, saya keluarkan kat sini. We have R equals to 20 Newton. We have RA equals to 0.38 meter. Always turn our distance to meter. We have, let's say ni FA ni. FA is 0.1 cm. 0.1 cm, 10 cm. No, 0.01 meter. 1 cm. And we don't know the F. So, in order to make this system balance, how much F do you need? Ni torque. Macam mana nak selesaikan? Okay, we have it something like this. Torque in this system is 0. So, torque equals to FD. Need to be equals to RD. F, we don't know it yet. D, berapa D dia? 0.01. Okay, ni 0. Torque. R dia berapa? R will be 20 and D dia will be 0.38. Can you find F? Selesaikan je lah. 20, 0.38 divide by 0.01. So, how much F do you have? 20 kali dengan 0.38 bahagi dengan 0.01. 760. What does it mean? What does it mean? It means that your bicep producing 760 Newton of force in order to balance up 20 Newton of weight. Ni adalah equilibrium. Why we need a lot of force? Because force arm pendek. Always remember this. When force arm pendek, in order to balance up weight, we need a lot of force. And the force need to be more than the amount of resistance. This is the concept of torque. Okay, this is concept of torque. Torque. Okay. Saya bagi satu lagi contoh. Katalah kita ada pintu. We are going to observe this door from the top. Okay, this one is the hinges. Let's say A push the door to this side with 200 Newton. And the distance between A to the axis of rotation is 60 centimeter. While we have another person pushing the door here. We name it as B. But we don't know how much Newton. The thing that we know is the distance between the hinges and B is 45 centimeter. Okay, my question. How much is X if we want to make sure the door does not move? Meaning dia tak pergi sana, dia tak pergi sini. It stay at its place. How much is B? This is a concept of torque. So you need to find out torque for A and torque for B. And combination of these two torque need to be 0. Torque summation of torque. So macam mana kita nak selesaikan ini? Okay, so we can have an equation like this. Macam yang ini tadi, kita buat satu-satu. Atau, when the system is 0, summation of torque equals to torque A plus torque B equals to FDA plus FDB. It need to be equals to 0. Cuma dekat sini, remember this one. Torque, okay, torque ni is a vector. Torque, it is a vector. When it is a vector, ingat benda ni. Nampak je vektor, ingat balik Cartesian coordinate. Anything that move downward is negative. Anything that move upward is positive. Anything that move to the right is positive. Anything that move to the left is negative. Ingat ini. Okay. Remember this one. So from here, let's solve the first one. FDA. So how much F for A? Berapa F dia?
200 Newton.
Tengok betul-betul. How much F for A? Ke bawah. Bawah.
Oh, negatif.
Yeah, negatif 200. Kalau lupa ni dia jadi lain. Okay, how about D dia berapa? Tukar jadi meter, 0.6. Plus, how much F for B? We know F for B? No, we don't know that. So, F, how much D? 0.45. Okay, so let's transfer this one to left hand side first. We are going to get negative F 0.45 sama dengan negatif 200 0.6. Boleh selesaikan kan? Negatif F sama dengan negatif 200 0.6 bahagi 0.45. So, liter negatif kita boleh padam. You can find out how much F. So, berapa F?
29.3.
Berapa?
29.3.
29. Sikit Ya ke? 200. Tak percaya tu. Orang dah bagi jawapan tak percaya. Dia rasa kau ni. 266.
Negatif 266.
Macam mana
Salah.
dapat 29?
Salah saya.
266. Okay, kita ambil kat situ 267 je lah. So, it will be 267 Newton of force. Kenapa jawapan dia positif? Because the direction. Ini konsep torque. Okay, this is concept of torque and equilibrium. Okay, we have 267 Newton in order to balance up this particular system. Ni konsep torque. This is torque. Okay, force, couple of force acting from different direction cause rotation. Okay, it cause rotation and you need to have axis of rotation. Okay, now we have torque. We go to the second one. Let's continue with the notes. Nota saya. Okay. Jauh lah ni kita jalan ni. Okay. Torque ni semua we have covered that one. Ni contoh tadi force, direction of resistance. Okay, this one is equilibrium. Why the concept of equilibrium present here is simply because whenever we are in anatomical position, in relaxed condition, we are actually at equilibrium state. Okay, itu konsep dia. So we need to find out how much torque happen at the force complex and how much torque happen at the resistance complex, and then you are going to determine the equilibrium of the system. Okay, ni contoh lah benda yang sama je ni. Okay. Alright, now we go to the second one, which is regarding center of gravity. This is center of gravity. Okay, abaikan ni dulu. Okay. Now let's further our concept of equilibrium and center of gravity. Kita ambil contoh yang sama where we are going to use ruler tu. Pasal ruler ni senang dia ada kiraan. Okay, this ruler. Right. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and finally 11. Okay, let's see. Okay, this is the axis of rotation. Kat berapa tu? Axis rotation dia 1, 2, 3, 4, 5, 6. So we have the axis here. Alright. Now let's see. We put one coin over here. what is going to happen to the system? Apa yang jadi pada sistem ini? It will tip. Okay, it will tip to a certain side. And it will tip here lah. Because the left hand side is much heavier compared to the right hand side. Okay, it's much heavier. Okay, how we want to prove that? Kat sini dia ada bagi satu contoh. Okay, nampak? Kat sini dia dah pakai benda lain. Dia tak pakai FD, pakai FR. It is the same thing. R is also distance. So now let's find out what amount of torque we have in the system. Okay, we have torque equals to FD or FR. Jadi F dia berapa? We assume the weight of this is kita assume dia sebagai duit shilling lah. Okay, the weight of this duit shilling is 1 penny. We don't know the weight, so kita pakai nombor dia. We have 1 penny. So the F now, berapa F dia? How much F we have in this system now?
Negative 1 penny.
Yes, good one. Negative 1 penny. Most of the time, people forget to put the negative. Okay, jadi kita ada negative 1 penny. Okay. Pergerakan ke kiri berapa banyak? 1, 2, 3, 4, 5. Negative 5. That is dia punya D. Okay, penny 5 cm. So you end up torque in the system is 5 penny per centimeter. Ni yang pertama. Okay, ni yang pertama. Belum habis.
Memang kena letak negatif 5 ke?
Kena. Kena letak negatif 5. Pasal dia ke kiri.
Walaupun dia bukan saya nak cakap ni
Kan-
kosong ke kiri tu kan baru start negatif kan. Kalau macam ni
Ni axis kita kat sini.
okay.
Saya faham soalan kamu. Nanti soalan yang kedua, kita guna yang macam kamu cakap. Jadi sekarang kita cerita bahagian. So we have axis here kan. So pergerakan ke sana, nampak nombor ni kita dah nombor ni sebenarnya nak tunjukkan jarak. So okay, boleh
Boleh.
ingat ni negatif. Okay, now let's say we have another penny being put here. 1 penny. Okay, soalan saya. Balance tak? Kalau tengok macam ni, kalau tengok pun nampak tak balance kan? Macam tak, memang tak lah. Sini 1, 2, 3.
Distance je.
Ni
Beza.
1, 2, 3. Mana balance? Okay, now let's see the resultant torque. Sekarang kita akan tengok berapa total torque yang ada dalam sistem. Okay, so we have FD1 plus FD2. Ni FD2. Okay, so kita ada 5 plus dengan F dia berapa kat sini? Negatif 1. Berat ke bawah kan? D dia berapa? 1, 2, 3. Now it is positive. Okay, jadi kamu dapat 5 minus 3. Hasil dia 2. Okay, hasil dia 2. Meaning that, number dia ni positif kan? Meaning that, in order to balance up this system, we need to add on another positive 2 torque. Okay, macam mana kita nak dapatkan positif 2 torque? How can we get a positive 2 torque? You know that when we want to get positive, it will be at the right hand side lah. Macam mana kita nak dapat 2? And you know that every penny is negative.
Jauhkan dia daripada axis.
Ataupun kita boleh tambah lagi satu
Penny.
We can tambah lagi satu penny. Dekat mana kita nak tambah?
Kat 11.
Salah.
Kat 7.
10.
Dekat 8.
Kenapa so?
Kenapa suka hati saya nak tambah penny kat mana kan? Okay, kenapa? Now let's see. Kenapa kena tambah dekat 8? Bukan 10, 7, 11. Okay. Saya buat satu-satu ke nak buat semua terus? Mana lagi senang? Satu-satu lagi senang. Okay. Kita tengok this side first. Torque 1. And this side, kita namakan dia sebagai torque 2. Okay, berapa banyak torque kita ada dekat torque 1? Torque 1 equals to FD. Sama dengan ni kan? So, kita dapat 5 penny per centimeter. Now, let's see torque 2. Torque 2 equals to FDA plus FDB. Namakanlah macam tu. This one is A, this one is B. So, FDA, F is negative 1. D dia 1, 2. 2. While FDB, F dia still negative 1. D dia 1, 2, 3. Now we have negative 2 tolak 3. We have negative 5. On the right hand side and on the left hand side, we have 5. Is it balanced out?
Balance.
Balance. Equilibrium. Center of gravity. Okay. Kalau kita sekalikan. Okay, kita sekalikan. Summation of torque equals to FD1 plus FDA plus FDB. Okay, FD1. F semua negatif 1. 1 penny kan? Negatif 1 penny. D dia negatif 5. Tambah FDA. Negatif 1 penny. D dia 2. Tambah negatif 1 penny. D dia 3. So we have here plus 5 minus 2 minus 3. You have 0. So the system does not have any torque. The system is balanced. Dapat? Ini konsep center of gravity. There you have it.
Faham saya, faham.
Senang kan? Mana ada benda susah lagi kira. Okay. Now I give you second concept of center of gravity sebelum saya bagi satu soalan yang menyusahkan kepala. Okay, sekejap konsep sama juga. Kita akan pakai penny. Pasal penny senang nak kira. Sekejap mana penny saya? Lost all the pennies. Penny, 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 penny. Penny. Where's the penny? Okay. We take the same situation. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, siapa benda ni? 10, 11. Okay. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's say now we put penny like this. Kita ada 6 penny. 1 penny, 2 penny, 3 penny, 4 penny, 5 penny, 6 penny. Okay. So, bila kita cerita konsep center of gravity, it see that there will be a point here where the mass is distributed evenly. Meaning that if we put this 6 penny like this, and if we put penny like this, 1, 2, 3, ada 6 lah ni. Okay. It will serve the same purpose. Maksudnya kalau kita timbang 6 penny dengan pembaris ni, berat dia ialah 10 gram. Dalam keadaan begini pun, the distribution is always going to be 10 gram. Ini konsep center of gravity. So, now, based on this 6 penny, we try to determine which point is actually dia punya center of gravity. Itu yang kita cuba nak cari sekarang. Okay, where is the center of gravity? At which numbers? Okay, to do that, we are going to consult.
Sir,
Yeah.
Kita cari center of gravity ni maksudnya point tu akan jadi dia punya axis yang dia stabil lah kan.
Dia bukan jadi axis, tapi dia akan jadi satu point yang mana dekat point tu berat adalah equal dekat semua bahagian. Contoh macam badan manusia kan, we have our human body ni. Dekat bahagian mana our weight is situated, most of the mass is situated. Dengan kata lain, kalau kita ceraikan bahagian ni, bahagian yang lain ni terpecah, the weight is actually equal. Itulah center of gravity, that is center of mass.
Ni talk juga ke sir?
Ini torque juga. Pasal kalau tak ada center of mass, kita akan berpusing-pusing. We are going to have a rotation if the weight is not evenly distributed. Okay, macam ni lah. If you stand straight, kamu rasa kamu balance tak bila kamu berdiri saja? Do you think you are going to be in a sense of balance? Dapat tak rasa tegak berdiri kan? Berdiri tegak, lepas tu kita tak rasa kita bergerak dekat mana-mana kan? That is when the mass is evenly distributed. So there are no acceleration to any direction. Tapi cuba berdiri yang sama, but now dekat dalam bus, where the bus keep on moving and braking, means that your center of mass keep on moving forward and backward tau. Kamu akan rasa sekejap bila bus tu bergerak laju, you are going to feel that you are going to move backward because your center of gravity is moving there. Now at that point, the mass is not evenly distributed. Bahagian perut berat, bahagian kaki ringan, ada macam tu. So you move. That is the concept of COG and COM. Dua-dua benda ni sama. Kadang-kadang dia nak keliru, dia keluar center of mass. It is actually the same. So what we are going to do today, I'm going to show you how to find that point. Okay, that point based on this system. If we talk about human system, the way you try to find it out is actually the same. But macam mana nak cakap mathematical model is similar. Cuma where the parts that is different. Contoh macam yang ini, the part is actually pennies being placed randomly. Okay, kalau human means we need to know pennies tu kan. Pennies ni bayangan dia macam this is one penny, 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 this is one penny. If we combine all of this penny, where is the center of all this mass being placed or located? Tu dia. That is the concept. Okay, so concept dia sama. So I'm going to show the concept. In order to do human like this, what we need to do is kita kena ada lukisan rajah dia, the sketching of human doing a certain action, and we need to find out the center for every single segment. Kita kena cek center dia dekat mana. Because this center will serve as dia punya D. Okay, and the weight of that particular segment will serve as dia punya F. Sama lah macam yang ini. Penny ni dia punya F. Distance ni dia punya D. So the concept is similar. To do this one, we need to have a template known as Welton template. Okay, cubalah cari dekat online. Dia dalam satu A4 dia akan bagi kamu banyak segitiga macam ni. Okay, dalam segitiga ni kamu akan ada a lot of line and a line dividing. Okay. So apa guna Welton template ni? I try to find this one, but up until now I still unable to locate this template, you know. Siapa jumpa, kita kongsi. Saya tunjuk macam mana nak pakai. This template, dia akan letak kat situ, abdomen. Dia akan letak kat sini, hand, leg. So we are going to actually put this template onto the body parts. Contoh leg, okay, lower leg. Kita akan pakai Welton template leg, and we are going to find out line yang betul-betul sama dengan panjang kaki model yang kita ada, and we are going to mark dia punya center. So we know dia punya D. Dia macam tu. So if you find Welton template, we are going to discuss about human. If not, we are going to discuss about konsep. So kamu punya exam pun dia takkan tanya Walton template ni. Ni zaman kuno. This is actually how everything started from. Okay. So yang terbaru ni basically we just put the point and the computer will calculate it for you. But if you don't know how the computer calculate, kamu pun tak tahu sebenarnya dia jadi macam mana. So that is how we determine human, okay, human center of gravity based on pictures. Sekarang kita dah ada 3D, we don't need pictures. Okay, kita kembali kepada penis and how to determine center of gravity with that. Okay, so the equation that we are going to consult to determine center of gravity here is still top. Okay, but summation of all top. The equation is this. Summation of top equals to summation of all the top in the system. Top 1, kita namakan dia ni A, top B, top C, top D, top E, and top F. Okay, and it need to be equal with the summation of weight in the system and the new R. This new R, this new D will determine the location of the COG placement. Okay, so here in this case we are concerned with figures regardless of direction. Okay, we are concerning of figures regardless of direction. So we are going to read everything from here. This is the right direction. Always start with that. Okay, since we want this to be equal, so we need the summation of top to be 0. Okay, to since we need the system to be in balance, so we need top to be 0. Kalau dia tak 0, dia akan bergerak lah atas bawah. Okay, next one. We are going to assume the weight of this thing as 1 penny, sama macam tadi. And since we don't need to know the directional term, we just need to know the placement je sekarang. Kita nak letak, kita tak nak tahu atas bawah. We just want to know where is the location. So we are going to assume the weight of every penny is 1 penny, bukan negative 1 penny. Pasal kita tak nak tengok dia bergerak, kita nak tengok dekat mana tempat dia. Okay, so please read the question. Okay, the first part ni, okay, this is the first part, sorry. First part kita dah ada kosong, second part and the third part. So the second part is actually the summation of all available top in the system. Let's go one by one. Okay, this one is the first one, second one. Okay, equals to, kita selesaikan nombor 1 dulu. Dia akan jadi macam ni. FDA plus FDB plus FDC plus FDE plus FDD, FDE, and finally FDF. So we have here 1 times 1 plus 1 times 3 plus 1 times 5 plus 1 times 7 plus 1 times 9 and finally 1 times 11. So kita ada 1, 3, 5, 7, 9 and finally 11. Okay, berapa total ni kita ada? 20, 36. We have 36 penny centimeter total of torque in the system. Okay, and number 3, okay, this one, total W. Total W is just total of weight or total of force in the system, and R. Okay, so this is the second part. Equation dia, ET equals to summation of WR equals to summation of W times R. Jadi 36P per centimeter ni, this is the second equation, equals with summation of W sahaja. So we have FA plus FB plus FC plus FD plus FE plus FF. Dekat luar dia baru R. Ataupun dia punya D. Okay, jadi kita ada berapa ni? 1, 2, 3, 4, 5, 6. 6 R. So, can you solve this one? Ni 6 ni 6P lah. 6P dengan R. Jadi R equals to 36P per centimeter over 6P. So R ialah 6 cm. Means that if we stack all of this coin dekat 6, it will be a balanced system. Ataupun it will be in equilibrium. Means no torque. Ni center of gravity. So when we talk about center of gravity, means we try to avoid acceleration. We try to have a point where everything is equal. Ni lah dia point dia. And this is how we find out center of gravity or center of mass. Selesai. Okay. Senang je kan? Pendek je hari ni punya ni. Ada soalan? Okay, dapat tak?
Dapat sir.
Yeah.
Alright. So any question regarding what we have discussed today? Dalam ni adalah nota-nota sikit ni. Okay. So kalau tak ada soalan, let's try this one and then we are going to end the class. Okay. Kita ada apa ni? Kita ada weightlifter has mistakenly placed a 20 kg plate on one end of the barbell and a 15 kg plate on the other end of the barbell. Barbell is 2.2 meter long and has a mass of 20 kg without the plate on it. Barbell je 2.2. Jadi tengah-tengah dia 1.1 lah. Okay, that is the middle of it. Okay, the 20 kg plate is located 40 cm from the right end. This one is 20 kg, 40 cm. And the 15 kg plate located 40 cm from the left end. Ni 40 cm. Tadi kita ada 2.2. Tolak 40. Dapatlah 1.8. Okay, daripada sini 1.8. Where is the center of gravity with the weight plates on it? Kat ni. Pergi kira lah. Dia dah bagi diagram. Dia dah bagi diagram, dah senang hidup tu. Try to find out where is it located. Where? Ni, tengok tu dia bagi mass tau. Dia bukan bagi weight. Okay. They give you mass. They are not giving you weight. So dekat sini ada dua cara untuk kamu selesaikan masalah. Satu cara is convert that mass to weight. Cara kedua, we omit the gravity out of the equation. Pasal kita nak tahu tempat je ni. Okay, kita just nak tahu dekat mana. Okay, both of the way is actually permissible to be used. Okay. Boleh? Dapat tak? Macam mana nak buat? Cara macam tadi. Cara macam kita tentukan center of gravity tadi. Okay. Saya akan keluarkan diagram dan maklumat yang ada. So it said that the first one, we have a barbell. And this barbell is 20 kg. Betul tak? Barbell 20 kg. Okay. Kita letak sini. Barbell 20 kg. And the length, ataupun the length lah. The length is 2.2 meter. Meaning that this 20 kg, okay, the midpoint is 1.1 meter. Width most of the time weight being distributed in the middle. Tu kamu kena ingat. Kalau tak ada apa-apa idea langsung, weight being distributed in the middle. So this 20 kg is located here, 1.1 meter. Tu yang pertama. Yang kedua, we have the first weight, we name it as weight A. Okay, weight A equals to 20 kg, and we have another weight here, name it as weight B at 15. That is the mistake. Okay, dia tersalah api. Okay, now all of this equation start from the right. Pasal dia cakap dekat sini, the 20 kg plate is located 40 cm from the right end of the barbell. Ni jarak ni. Okay, so kita ada D for A is 20 cm, 0.2 meter, and D for B is, dia cakap dekat sini, located 40 cm towards the end. So kalau daripada sini, kita nak tentukan location, we take one point. Okay, we take from one end saja. Pasal kita nak tahu dia dekat mana tengah dia. Kita jangan ambil daripada kiri daripada kanan. If we try to determine dia sengit ke mana, and then you are going to divide this one into positive and negative. But if we try to determine a point or location, we start with only one end. Jadi, we start as similar as A. If this length is 2.2, divide with 40, this length, okay, the length between the end with B is 1.8 meter. Okay. Tu yang kita dah ada sekarang. Ni kenapa 0.2 pula, 0.4 lah, 40 cm. Okay. So, kita dah ada 1D, 2D, 3D, 3 weight. Alright. Okay, now, the question is, where is the center of gravity? Jadi kita pakai equation yang sama. We are going to use ET equals to summation of FD equals to summation of FD. And this D will determine where. Okay. So we know that when we talk about F, it is not in kg, it will be in Newton. Okay, dia adalah dalam Newton. Tapi this is tapi. You can change this to Newton, you can change all of this to Newton, or FD ni, okay, saya tunjuk dekat sini FD ni is also equal with WD ataupun WR kan. Okay, WD ataupun WR. W ni is mass time gravity. Jadi dia boleh jadi macam ni, mass times gravity D. It can be like this. So kita dah ada mass, kita tak ada gravity. Okay, kita ada mass, kita tak ada gravity. If we write down this in full form, dia akan jadi macam ni. Kita ada 1, 2, 3. So kita ada FDA plus FDB plus FDC. Okay, dia boleh jadi MGDA plus MGDB plus MGDC. Okey. Dalam tiga-tiga equation ni, tiga-tiga ada G kan? And we don't have G in mass, betul? Setuju?
Setuju.
Okey. Kita boleh keluarkan G tu. Jadi dia akan jadi macam ni. It will be MDA plus MDB plus MDC G pun boleh. Pasal yang kita nak sekarang place. We don't need to know the weight itself. Cuma formula dia ialah weight force kan. Ini salah satu cara. Tapi kalau kata aduh pening nak ingat semua benda, okay fine. Just use the original equation. Change all of this mass into weight first. Settle lah masalah. So we times with 10. We have 200 Newton. We have 200 Newton. We have 150 Newton. Dah, settle masalah. That is what I mean by we have two ways to solve this. Okay, now, based on the information, the new converted value, let's find out what is the new R. Where is the center of mass in this system in order to make the system equilibrium, in order to maintain no torque at the barbell, or else you are going to fall down. Kita gunakan equation asal, which is torque equals to summation of FD equals to summation of F and D. Okay, here we have 0 since we don't want anything to move. FD kita ada 3. We have FD1 plus FD2 plus FD3 equals to F1 plus F2 plus F3D. FD1, kita ambil lah ni, dumbbell ni kan. So kita ada 200 Newton dengan mid dia 1.1. So we have 200 1.1 plus FD2, kita ambil lah satu dumbbell ni. Nak ambil yang mana-mana pun boleh je sebenarnya, tak ada masalah. Dan jadi 3. Okay, FD2 kita ambil A 200 Newton and the distance is 0.4, and FD3 we have 150 and the distance is 1.8 equal to ni yang bahagian yang ketiga, where we have 200 plus 200 plus 150 D. Dah boleh selesai. Selesai kan? 200 kali 1.1 1.1 220 plus 200 kali 0.4. We have 80. And finally, 150 plus 1.8 plus times 1.8. 270 equals to 4550 D. So the D itself will be 300, okay, 300 570 bahagi 550. You end up dengan 1.04 meter. Means the midpoint for this system to maintain the equilibrium of the barbell is 1.04. Ini tadi 1.1, so dia dekat sini. Menghampiri kepada A in order to make the system menghampiri pada A. Betul lah? In order to make the system balance. Kalau menghampiri pada B, A jatuhlah ke bawah. So the system is not in balance. Adalah torque di situ. So this is how we measuring the center of gravity and how we play around with projectile, with torque and also what we call it, equilibrium in human performance. Alright, so that's all for today class. You have another half an hour, so please use the time to do some of the revision. Okay, and your quiz 1 will be conducted tomorrow during tutorial hours. Your tutorial will be 2 to 3. Betul? Betul tak? Khamis.
Yes, sir.
Yes, sir. 1 hour, sir.
Saya buka tutorial tu masa itu saja. Please don't be late and submit your quiz before the end of tutorial hours. Okay, the quiz is just 10 objective question. Pick up from all the topic that we have learned until the last week before Cuti Raya. Alright, do you have any question for today class?